Hello friends, today I thought to make a video which summarizes all the important concepts and formulae that we learned in the previous videos, which I think is a good way to summarize and revise everything if we have like exams nearby and we have to like recap everything in a very short amount of time. So let's see what we have. So we learned that soil is a three-phase system consisting of air, water, and solids. First, let's look at the phase diagram because that helps us to better understand each and every material. So we know soil contains air, water, and solids. We have the volume side on the left, the weight side on the right. This is volume of air, water, and solids. Similarly, on the right, we have weight of air, which is neglected to be zero, weight of water, and weight of solids. The air and water together make up what we call as the voids, and these voids can be filled with either air or water or both, and this helps to determine what the saturation of our soil is. Now we look at some important basic definitions of soil parameters. So the first one which we look at we know is water content, which is represented by a small w, and this is equal to the weight of water over the weight of solids. Second, void ratio, which is represented by E, and that's equal to volume of voids over volume of solids. Third is porosity, which is represented by an N and is equal to the volume of voids over the total volume, this big V. And the fourth one, which we'll look at, is saturation, which is represented by an S. It's equal to the volume of water over the volume of voids. I mean, how much of this void space is occupied by water is what we call as saturation. Note that the water content, the void ratio, the porosity, and the saturation are all dimensionless quantities because they are a ratio of similar quantities. So there's no dimension associated with that. Next important quantity what we look at is called unit weight, which is similar to density, but since it also involves acceleration due to gravity, that's why it's called unit weight. It's represented by gamma and is equal to the weight over volume. Now, depending on the type of soil we are looking at, we can either have a saturated soil for which we will have gamma sat, we can have a dry soil which is gamma d, and we can have a soil which has both, which is saturated, but we need to know the effective unit weight, which is represented by gamma dash. So in gamma sat, S equals to 1 or 100%. In dry soil, S equals to 0 or 0% as we want to call, and gamma dash is simply the saturated unit weight minus the unit weight of water. This unit weight of water is usually taken to be 9.8 kilonewton per meter cube, kilonewtons for the weight and meter cube for the volume, SI units. And sometimes it's also approximated to be 10 kilometer per meter cube for easy calculations. Finally, we have the specific gravity of solids, which is represented by G or GS, and that is the ratio of the unit weight of solids to the unit weight of water. So it's just like what we have relative density of solids with respect to water. Now this G lies between 2.65 to 2.8. Usually for sands, we have it's approximately 2.65, and for clays it's approximately 2.7. Something to remember and consider. Next, we'll look at the relationships among these various soil parameters, which can be derived using either phase diagrams or mathematical expressions upon interchanging. So we have some important relationships. Of the first one which we have is the weight of solids, soil solids, which was equal to the total weight of soil over 1 plus water content. The second one, we have the relationship between porosity and void ratio, which was n equals E over 1 plus E. And similarly, if we interchange and solve for E, we'll get n over 1 minus n. The third one is very, very important, and it's called ES equals to GW, the relationship between void ratio, saturation, spec specific gravity of solids, and water content. And finally, very important relationship for unit weight, which is gamma equals to gamma W times G plus SE over 1 plus E. Very important. And depending on the type of soil that we have, if we want gamma sat, then we just substitute S equals to 1. If we want gamma dry, we can substitute S equals to 0. And if we want gamma dash, we have that gamma sat minus gamma water, and that comes out to be equal to gamma W times G minus 1 over 1 plus E. So some important relations which we can learn and you directly apply in our exams. I think this should decently cover what we studied until now, and this will help us to quickly revise important formulae. Thank you. If this helps, please consider sharing this video with your friends. I would also highly appreciate it if you give this video a like and subscribe to my channel for more informative content like this. Your support really means a lot to me. So thank you and see you in the next video.